32. Find the rational zeros and then the other zeros of the polynomial function f of x equals x to the power of 3 plus 11x squared minus 5x minus 55. Solve f of x equals 0. This is A. For B, factor f of x into linear factors. Again, to find the rational zeros, immediately what you have to do, using synthetic division, use the theorem that we mentioned in the last video, which is last video immediately, the rational zeros theorem. So we have to use this theorem to do what? To find the potential rational zeros. What are the potential rational zeros? We look at the P and the Q. Where can we find P and the Q? P is the coefficient, or Q is the coefficient of the leading term, which is 1. This is a Q. Q is 1. And P is going to be the constant term, which is negative 55. This is P. This is P. This is P, not a Q, man. This is P, negative 55. So what we have to do now, we have to look at the quotient. We divide P over Q. So what are the possibilities now? The possibilities, all possibilities, P over Q. So we're going to have either 55. Ask yourself, what are the factors of the 55? Let me repeat. What are the factors of the 55? Either 1, positive or negative, 5, positive or negative, 11, positive or negative, 55, positive and negative. What about the Q? You have only 1, positive and negative. So what are all of the possibilities here? All of the potential rational zeros. Just divide. 1 divided by 1 is just 1, plus or minus. Then, erase this. Then, divide. 5 divided by 1 is 5, positive or negative, and so on. 11, positive or negative, 55, positive or negative. So these are the candidates to be the rational zeros. Which one are we going to pick? No, we are not going to pick. We are going to try these guys. So we're going to implement the synthetic division. We will be dividing the dividend, dividing by the divisor. We're going to pick the divisor, okay? We're going to take the divisor from these zeros. Then we're going to see if we get remainder 0, then we are done. So this is factor, so that means if it's factor, then this is 0. Okay, I'll do it in detail here. So to start with, we need now to pick one of these potential zeros and divide the dividend, which is the polynomial, over the first factor. So let's pick first. Pick number 1. I'm going to pick x equals 1. So I assume that this is a potential zero of the polynomial. So I'm going to take the coefficients of my polynomial, which is 1, 11, negative 5. 1 is the coefficient of x cubed. 1 is the coefficient of x cubed, and 11 is the coefficient of x squared. And we have negative 5 is the coefficient of x, and we have negative 55 is the constant. So we have all of the coefficients starting of the degree of 3, then goes down, okay? What is the 0? The 0 is 1 here. So we are going to test. How to do this? We bring down the 1, then multiply 1 times 1 is 1. Refer to the synthetic division that we did in the previous examples. Then 11 plus 1 is 12. 12 times 1 is 12. Then we got here 7. And 7 times 1 is 7. Then you get negative 48. And this is the remainder, and the remainder is not 0. The remainder here is not 0. Then 1 is not a 0 of this polynomial. Okay? Then I'm going to try another one, which is the negative 1. So I'm going to erase this and try the negative 1, minus 1. So this is minus 1 here. So now is what? Bring the 1 down. Multiply 1 times negative 1 is negative 1. Add these two guys, you get 10. Multiply 10 times negative 1 is negative 10. Add these two guys, you get negative 15. Multiply, you get positive 15. Then you get 40 negative, which is not 0. This is the remainder again, which is not 0. Then the negative 1 did not work. Now let's try something else. Let's try having what? Let me erase this. 1 doesn't work. So we're going to try what? We're going to try 5. Okay? Positive 5. Positive 5. Bring the 1 down. Then 1 times 5 is 5. Add these guys, you get 16. 16 times 5 is 80. Then add these guys, you get 75. Then multiply 75 times 5, you get a big number like 25 here. And we got 37. So this is big number actually. So this is not 0 again. So the 5 is not a 0 of the polynomial. So let's erase this and try something else. So I'm going to try the negative 5 now. So the negative 5, bring the 1 down. Multiply these, you get negative 5. Then 11 plus negative 5 is, we got 6. 6 times negative 5 is negative 30. Correct? Then add these guys, you get negative 35. Then multiply negative 35 times negative 5. What do we get? We get here 15 and 1, 7 positive. And this is also not a 0. So this is not a 0, okay? This is not a 0 as well. And let's try the 11. Let's try the 11. 11. So let's have 11 here. So 11, 1 down. 1 times 11 is 11. Add these guys, you got 22, right? Then 22 times 11 is something big. So it doesn't seem that 11 is going to work. So let's pick the negative 11. Negative 11. Here we have 1. Here we have negative 11. Here we got 0. 0 times this guy, we got 0. Then add these guys, you get negative 5. Then multiply negative 5 times negative 11. What did we get? We get positive 55. Oh, finally we got 0. This is 0. Very good. So what did we conclude? We conclude that the negative 11 is a 0, right? So the negative 11 is a 0. So let's do this now. Okay, now next, what is next? Since x equals to the negative 11 is a 0, then x plus 11 is a factor of f of x. So what do we have now? We have the dividend, which is the polynomial f of x. F of x is equal to what? Is equal to the x cubed, right? Plus 11x squared minus 5x minus 55. This guy is equal to what? Is equal to the quotient times the divisor. What is the divisor? Is this factor, x plus 11. X plus 11 times the quotient. Where is the quotient? This is the quotient. This is the quotient, highlighted in yellow. Times the quotient. What is the degree of the quotient? The degree of the quotient has a second degree. Why has a second degree? Because we divided third degree polynomial divided by first degree factor. okay? We got the second degree, okay? Because we divided by x plus 11, the factor. So we got second degree. So the first number is the coefficient of x squared. The second number, the 0, is the coefficient of x, so we don't write it because 0 times x is 0, then minus 5. So what did we do? We factored f of x as a product of two factors. Okay, the question is, can we factor more? Can we do more factoring? Yes, we can. The first one is a linear factor. The second one is not a linear factor. So we can still factor more. It's a quadratic, and this is difference of two squares. How do we factor x squared minus 5? We take the square root of x squared, which is x, and we take square root for the 5, which is the square root of 5. Then one of them is plus, the other one is minus. So now we factored f of x completely. We have three factors, a product of three factors. Can we find the zeros? Yes, we can find the zeros by equating f of x to 0. So equate or set f of x to 0. If you set f of x to 0, what you are going to get? X plus 1 times x minus radical 5 times x plus radical of 5 equals to 0. I'm going to use the 0 property because we have a product of three factors equals 0. So either the first one is 0, or the second one is 0, or the third one is 0. And get the values of x. So the first one, we're going to get x equal to the negative 1 by subtracting 1 from both sides, or adding radical 5 to both sides, or subtracting radical 5 to both sides. So we got three zeros. Which one of them is an irrational? This is an irrational. And this is an irrational. But this is the rational, 0. So back to the question now. Okay, now for A, we're going to select one of these choices. There are only rational zeros? No. The rational zeros is, and the other zeros are. Yes, we have this. So the rational 0 is negative 11. And the other zeros are what? Radical 5, negative radical 5. So this is for A. For B, the factorization into linear factors. So we got x plus 11 and times x minus radical of 5 times x plus radical of 5. That's it. So let me just recap quickly. What did we do here? We are given a function, polynomial function, has a degree of 3. The question asks you to solve f of x equals to 0. And the question asks you to factor f of x. So to solve f of x equals to 0, so we have to factor it. We have to find the zeros. The idea is to find the zeros of the function. To find the zeros of the function, I used the p's and the q's concept. This is the p, and this is the q, negative 55 and 1. And we took the factors, and we looked at all possibilities of having zeros by dividing p over q. So we have these possibilities. All of the factors of p's, all of the factors of q, then we divide them. We get all the possibilities of the zeros. Then I started pick one by one and implement the synthetic division. Why did I do this? Because I would like to divide the function f, the dividend, by one of the factors, okay? Then see if the remainder is 0 or no. If the remainder is 0, then we are good, because this is going to be a factor and the number that we picked is going to be a 0 of the function. After we found that we have a negative 11 as a 0, then we concluded that x plus 11 is a factor, and we rewrote the function f of x as what? As a product of the divisor times the quotient plus here the zero, the remainder, but we don't try the zero because it's zero, right? It doesn't change anything. After that, we continue factoring because we found that we have only one linear factor and the other one is quadratic, and we asked ourselves, can we continue factoring this? Yes, we can. It's a difference of two squares. Then we completed the factoring. After that, we found the zero of the function by equating these factors to zero, and we used the zero property. We ended up having one rational zero and two irrational zeros.